Okay, then, to solve inequalities like the one on the board, the first thing we do is we treat it almost like an equation. We're trying to draw the graph of this. It's something which I'm not seeing around the room, and I'll come to that later. But the first thing I'm going to do is try to factorise the left-hand side. There's an x there and an x there, greater than or equal to 0. Now, two numbers which multiply to make 16 and add to make 10, 2 and 8, good. So I saw that done pretty well, and it's at that point where I saw mistakes starting to creep in. The next thing that I would like to see doing is draw this graph. Draw this graph. The whole point of factorising is that it's easy to draw now. It's 0 when x equals minus 8, and it's also 0 when x equals minus 2, and it's the sort of a U-shaped way up. I'm not terribly interested in where it crosses the axis. This is working a bit slow on the board there. Just it'll catch up in a sec. But now comes the bit where I didn't see. This is greater than or equal to 0. It's greater than or equal to 0 here and here. It's certainly not greater than or equal to 0 here. So some of you have got precisely the wrong answer to this. The greater than or equal to 0 bit is here and here. Two bits require two separate bits of solution. The first bit is x is less than minus 8, and the second bit is x is greater than minus 2. So those are the two separate solutions. X is less than minus 8 and x is greater than minus 2.
Less than or equal to.
And it's just been pointed out to me that I missed off the or equal to sign, which would have been a disaster, so that's now correct now. Inequalities like this one, the first thing to do is to, just like you would do with an equation, to get everything over onto one side. So x squared add 4x minus 2 is less than 0. And then our task is again to factorise. Now, it doesn't look like it's going to be that easy to factorise to me. So next stage looks like resorting to either completing a square or quadratic formula. So these are called critical values. The critical values are when it equals 0. Right, the critical values are when it equals 0. We want it to be greater than. So the critical values are where it crosses the axes. And that's x equals minus b plus or minus the square root of b squared minus 4ac, which should be something like that. Minus 4 times minus 2 divided by 2. So we end up with minus 2 plus or minus, that's the square root of 24 over 2. 24 is what?
It's 12. It's root of 12.
No, the square root of 6. Something like that. Anyway, now I draw the thing. Minus 2 plus root 6. Minus 2 plus root 6. Well, root 6 is a bit more than 2, so minus 2 plus root 6 is going to be positive. That's minus 2 plus root 6. And minus 2 minus root 6 is over here. And now I draw the thing. And I draw the thing this way round again. And it looks something like that. And I want it to be less than 0. I want this black graph to be less than 0. So it's the bit underneath this time. It's this bit here. So it's the bit in between those two values. And the way to draw that, the way to write that, is always start with the smallest value. X is between the smallest value and the largest value here. So x is between that value and that value. And the way to write that is minus 2 minus root 6 less than x less than minus 2 plus root 6. So written like that. Notice here, if x is between these two values, x is between minus 2 minus root 6 and minus 2 plus root 6, then the way to write the final inequality is just as you'd read it. X is between minus 2 minus root 6 and minus 2 plus root 6. And always write the numbers in order, like I have done on the board. Some of you have written minus 2 and then minus 8 on the other side. Minus 8 is smaller than minus 2, so if you've got anything like that, that's not correct.
So it's only if it's less